Did you know that soccer is the most popular sport in the world? Thought so. And who doesn't like to kick a soccer ball? Well, it's admittedly really fun. However, did you ever wonder how the ball actually ends up moving? Let's check out. Yeah, that's not gonna happen by itself. For the ball to move, there needs to be something causes its motion, just like a kick. That's exactly what usually happens in a soccer game.
Now how does that kick, or rather the contact that the foot has with the ball, cause it to actually start its motion? A seemingly straightforward event, the kick is actually a complex form of energy transfer, or simply put, a collision. Let's go ahead and take a look at what happens before, during, and after the collision that's experienced by the soccer ball. Let's take a look at a few key things that take place in the collision. Firstly, the shoe touches the ball, which is the exact moment of contact. The shoe then continues its motion against the ball, and the ball does not immediately move. But as you can see, there is a slight compression in the ball, along with a vibration that is due to the impact from the shoe. Thereafter, the ball begins to move, accelerating until there is no longer any visible compression, and it has moved away from the shoe.
There are different ways of looking at what happened. We will start with the momentum approach. The foot, with a certain amount of momentum, comes into contact with the ball, which is at rest. Now, what is momentum? Momentum is a product of an object's mass and velocity. Therefore, the foot has momentum and the ball does not. As the foot continues to move and compresses the ball, it decelerates, and therefore it loses its momentum. As a result, the ball vibrates as momentum is transferred from foot to the ball. You may have noticed though that this does not give us the whole picture. The foot loses momentum and slows down, but for a moment, the ball simply compresses and does not move.
And thus, we consider the energy approach.
Let's go back to the video to get a better look. To begin with, the player's leg has a certain amount of kinetic energy, as can be observed by the fact that the leg is in motion. When the player's foot collides with the ball, it loses some of its kinetic energy. The ball, on the other hand, experiences a compression. What's going on here? Well, when the ball experiences the compression, there is actually a transfer of kinetic energy from the foot to elastic potential energy to the ball. Now, Newton's third law of motion states that for every action force, there is an equal and opposite reaction force. Considering this, the kinetic energy being transferred to the ball as its motion begins results in two things. Firstly, the foot pushing against the ball, and the ball pushing as a result back against the foot, causes an increase in kinetic energy, or acceleration. Secondly though, when the ball is compressed, elastic potential energy is stored inside the ball in the form of increased air pressure. While the foot is pushing with a force against the ball, the elastic potential energy is released, causing an increase in net force. The ball consequently pushes harder against the foot, therefore launching itself more quickly into the air.
And that's how the ball ends up moving.